Always remember to do your own research as some of the tools that I'm about to show in this series are very new. Hey, welcome back to the series where I'm building out an NFT card generating tool from start to finish. Just a recap, in the previous video, we completed a few tasks, we set up Node.js, we also added a cool functionality to configure and validate our environment variables. Today's goal is going to be to see if we can create the NFT ID scanner and possibly touch on the metadata resolver task as well. If you want a recap of the full series, I highly recommend watching this playlist from start to finish, as in this series, I show you how you can properly plan your project, define epics, user stories, process flows, and the tasks that we are now busy coding. So with that, let's just jump into it. So up until this point, if we refer to our system design, we have set up this entry point, basically run.ts, and in here we have configured some environment variables. Now we haven't configured the actual ones we're going to use. We've just done that step in the process where we validate variables that they are set. So in today's video, we're going to look at this part, the Ethereum NFT ID scanner service that we need to build out. So we can see that we'll need some sort of interface. We need a class that's going to be the implementation, and we need to use ethers.js to get this right. And then this service is going to reach out to the Ethereum RPC. So we need to get some keys from maybe MetaMask. We'll see out in Infura. And then we're going to just retrieve that back with hopefully a list of NFT IDs that's on a wallet from a specific NFT contract. Now that we know that we need some access to the Ethereum blockchain, we can do that through an RPC. A great service to use is Infura. So basically, this is by MetaMask, I believe. You can sign in, and I've done so. And then you just create your first key and make sure that it's on the Ethereum mainnet or testnet or maybe Polygon, whatever you want to create. However, I did already create one set of keys for me here that I'm reusing. I cannot reveal the actual value, so you'll just have to enter your own value there. But here is mine. And so, yeah, once you have that, you're going to click on this and you're going to save that key somewhere later for configuring it in our environment variables. Now with the key in hand, we can get to our .env file, and let's just go ahead and create a new key, which will be RPC provider URL. Now, this is what you'll get from Infura, this entire string or this URL. And at the very end, you need to replace your key here that you got from your API. So it will end up looking like a bunch of characters like this right here at the end. But yeah, I can't reveal mine, so you'll need to do that. However, for time being, I'm just going to do this as a generic key that I'll use to illustrate how it should look like. Great, so let's go ahead and look what is next. Referring back to our system design, we know that we have covered the Ethereum RPC, at least from a credentials point of view, getting that from Infura, and we've set that in environment variables. So now that's next is we need to go ahead and define this service, the Ethereum NFT ID scanner. And again, just to reiterate, this is the purpose of this is to pass to the next process in this step a list of IDs, and these will be NFT IDs that a specific wallet holds of a specific collection and a specific NFT collection. So if we just look at it from an OpenSea level, we're going to select this one, which is the Sketchy Ape Book Club NFT collection. This is the entire collection. And if we have a look here, clicking on any of these NFTs, scrolling down, going to details, we can see the contract address. So this is one of the environment variables we'll need. This is the NFT collections address. And then we also need a wallet that holds some of these NFTs. This wallet I created, it's a newly created wallet, meaning that I do have the public key and I also have the private key, which is very important. This will act as our transfer wallet eventually. But this wallet specifically, the NFTs that it holds are 4 of the Sketchy Ape Book Club NFTs. Okay. Now, why do we need this? Well, if we go ahead and look at our process diagram, so here we can see after scanning the actual variables and making sure that they are there, we're going to enter the process that we'll be making and coding. This is to fetch the NFT IDs from a specific wallet. That's the wallet I just showed you. I have the public and the private key of, and there are some NFTs from a specific NFT collection in here. When we do find that there are some token IDs present, we're going to return it to the next step in the process. Otherwise, we're just going to go no, and we're going to exit with an error and end. So that is what we will need to focus on. So with that in mind, now we need to set our environment variables and add some more keys. So the keys, firstly, is the main NFT contract address. This will be the address of the entire NFT collection, and this could be any collection that you own. So please do not use this one because this is the main collection of the Sketchy Ape Book Club, but this will work. Whoever owns some of these NFTs in this wallet, it should work. Okay, so that's the main NFT collection address. Then we have the NFT holder wallet address. This is the public key. This is fine for me to show. And then lastly, you need this wallet's private key over here. This one I cannot reveal to you. That's why you need to replace it with your private key. And when I speak about this, at this point, I do have to mention that the stuff I'm showing to you, you need to be absolutely sure that you know what you are doing. This is extremely dangerous to work with private keys and funds that you send around with this program. So if you do not know and you're not comfortable with code and you're not sure about private keys and public keys, I would recommend that you do not follow along with this tutorial, and especially because it is really secure, sensitive stuff that we're dealing with. However, if you're comfortable with it, then that's fine. So I'm going to take this arbitrary number and I'm just going to put it here so we have some reference, right? And we've replaced it with a private key, quote unquote. So this should be a very long number like that. Obviously, this is now fake. So yeah, so far we need these environment variables. And when I run the program later on, I'm just going to replace this one and this with my actual keys so we can successfully run it. The next thing we can do is head over to the run.ts. Remember we configured this to check that these environment variables are set? Well, now we don't have them and we have new ones. So we can replace that one. We need the NFT contract address. We're also going to need a new one. So this, and then the private key one. So this will make sure from our previous video that when we run this, these are set, and then we have these variables. So if we run this, this should now still work and give us back none, as we see here, because we do have the key set. Okay, cool. Okay, so we can now move on to creating the actual class now that we have a log configuration. I'm going to start off by creating this interface. So in my interface folder that we've set up, create a new file and call it NFT ID scanner service interface.ts. Then we can go ahead and define the interface. So we can export this, and this will be our interface. The interface is useful to create boundaries of what we do need to implement when it comes to an NFT ID scanner service, so that we can swap out different services. For example, we're going to focus on Ethereum, but we can create a Polygon or maybe a different chain scanning service too. So we just need to define what type of functions this will have. Now, in this case, it will only have one function, which would be scan. Maybe we can say token, scan token IDs. That should be fine. This is going to be a function that's going to return back to us a promise. And this promise will be of type. So all the NFT IDs will come back as a string array. Okay. So this is going to be our interface. And now we can go ahead and create a new class that implements this interface. And the class that we're going to create is this service basically. And now we're getting down to the implementation details. That's why if we go to our services folder, we can just create a new file and create this one. Let me create more space. You can see basically the actual implementation of this is Ethereum NFT ID scanner so that we can know what chain this scanner is for. Okay, so here we can go ahead and export a new class, and our class will be for the Ethereum NFT ID scanner. And this will going to be implements the NFT ID scanner service. Okay, so this will be our class. If you look over here, our Ethereum NFT ID scanner service is red. And if we read there, it's because we do need a property or a method that is basically scan token IDs. And that's because we implement this interface. And that's what the benefits are of using an interface like this. Okay, so let's go ahead and implement this function. And the function was scan token IDs, and we can make this synchronous. So now this is also red because we need to return an array of strings. So we can just now, for time being, can just return an empty array. Okay. Now it's very happy, but this is not very useful. We actually need to now reach out to the RPC service, use the RPC to go and get the data from that contract and see what tokens are on this wallet so that we can actually return some values. Now, in order to get these tokens, we do have the configured variables that we have here, but to make it easy for us to read and interact with the blockchain, we can use the library ethers.js. So here at the bottom, we can just install it, npm install ethers. And this will make it easy for us to create maybe an instance or like read from the blockchain via the RPC and such to get those values back. So we can now use it in our function here. Now, the first thing we're going to do at the top of our class, let's define some private variables and also import ethers. So we're going to import ethers over there. Now, the variables that we're going to define is firstly the top one here, which is the RPC provider. Then we have the NFT contract address and the NFT holder wallet address. Okay, so we need these variables, and where we can get them is in our constructor. But what I would like to do is at the top here, define options, and then inside of our class, when we do define our constructor, we get to use the options. This just makes it a little bit more type safe. So what are we doing here? We're basically saying in our constructor, when we instantiate the class, we're going to provide the URL, so the RPC provider URL. Then we're going to provide the NFT contract address and holder wallet address, and these will be assigned to our internal private variables here. Okay, so the next thing for us to do is to create a contract instance so that we can read the values from it. But before we do that, let's go ahead and wrap this in a try catch block. The reason for this is so that we can catch any errors that occur and immediately stop the process. Now, if you remember from the previous video, we created this app error, and that's basically what we want here, so that whatever we do in the try, if that doesn't work out, if we pick up any error, if some process fails, at least we get this catch where we can inform what happened, which step in the process, and then just stop right there. Next, we can go ahead and create a variable and call this contract. And this will be equal to a new, and here we can do ethers.contract. And now we create an instance of the contract. This is so that we kind of have a replicated instance and know what variables and functions we can call on it. Now, if you hover over the contract, you can see that we can provide a few things. Firstly, we need the address, then we need the ABI, and then we can also provide the provider. Now, if we just go briefly for 1 second back here, we can see on Etherscan on this NFT contract, if we go there, we go down, this is the ABI. It's basically the rough instructions that's available on this contract for us to call. However, we're going to provide a minimum ABI, so we don't have to specify all the functions in this contract as we don't need it all. But let's start off by first providing the NFT contract address, like so, and then we're going to provide a minimum ABI. Our ABI will have the transfer event, as this is what we're going to be using to track the actual amount of NFTs, and then also owner of function. And then lastly in here, we can just specify this dot RPC provider. Okay, cool. So now that we have an instance of this contract and some functions that we can use, and that is great. And now we can go ahead and create a filter for what we want to search for. And this is why we've used this transfer event. Now, how contracts work is, especially the ERC 721 contracts and a bunch of others, we get events, but the ERC 721 would have a transfer event like you can see over here. And a transfer event contains specific information of where an NFT was sent to, and it has the token ID. So we can kind of use this transfer or these transfer events, scan them for a specific owner, and then go and see actually how many NFTs they still have. And that's a smart way of picking up the NFTs in a wallet. Okay, so let's go ahead and create our filter. So we can say filter is going to be equal to the contract. So now we can reference this contract here at the top. We can say filters because we want to filter on the transfer event, and we can just pass here null. And here we can specify the wallet holder address. This is what we want to filter by. Next, we can create another variable, and this will be our event that we now need to go ahead and query. So we can await this. We can again say contract dot query, so query filter, and then pass in our filter over there. Okay, so now we get all of the events back based on this wallet holder's address. So we'll get all those events, but we need some more informative information there, right? So we want to say that we want to get the token IDs, and this will be our array. We're going to expand this. And to make sure we have unique values, we can use a set. We're then going to get this event, and we'll map over this. And then we need to now make sure that we return something back. So what we want to get is we want to get, let's just say this could be of any, but we do know that into args, because there would be arguments in there, and then we can get the token ID, and then let's just make sure that this is toString. So now these token IDs are all the token IDs where this wallet was associated with. So it's going to have no duplicates, yes, but also we do not know if this person or this wallet address still owns them. So the next step for us is to verify the ownership if these tokens are still in their wallet. And we can do that by calling the owner of function. Now let's go ahead and create a new variable, and we're going to call this own token IDs. This will be of type string array because that's what we want at the end of the day. And we'll set it to empty for now. Now we can go ahead and create a for loop. We're going to loop over the token IDs. So we can just say token ID of the token IDs here at the top. Now inside of this for loop over here, we can also do a try catch. Remember, we're going to reach out to this contract again. So if anything goes wrong, we do want to know about it. So what I'm going to do here is I'm going to soft warn if something goes wrong here, because sometimes we don't want to just fully stop the process. We just want to literally get back the successfully owned token IDs that we can actually verify here in the try. If we can't, we're going to actually just warn and say, fail to verify ownership of this token, and that is it. Now in the try block, what we can do is we can get the current owner. Now we can do that. Remember, we do have our contract up here that we can use, and we do have this owner of function. So in here, we can just await the contract. We can say owner of, and then just pass our current token ID that we have in our for loop. And now it's very straightforward. We just need to make sure that this address actually matches our NFT holder wallet address there at the top. And if so, we're going to push it to these tokens over there. Okay. So what we can do is we can open up an if block. We can say if the current owner dot to lowercase is equal to the this dot NFT holder wallet address to lowercase, just so that the comparisons does pan out. And only if this is the case, we're going to say the owned tokens here dot push, and we're going to push the token ID. Okay. So now this ensures that the own tokens are really the token IDs that is left in this person's wallet. Now, lastly, we can do some cleanup checks and also add a few logs. One check that I want to add before we actually return these own tokens, and now here at the bottom, we can return the own tokens. But before we do, I would like to add an extra check. And this is just to check if the own tokens is equal to 0. We throw an app error and let the person know, well, there is no tokens in here. Okay. And then what I do want to do is once we are happy with this, just before we return, I'm going to log out the amount of tokens that we found. Also here at the very top of our try block, I'm going to just start the process off with a log as well. This will let me know what wallet we are scanning so that in the console, we actually get some good feedback of what's happening and also start seeing things in the terminal as the program runs. Great. So that is it for our Ethereum NFT scanner. I think we did well and it's ready to test out. Now, we need to actually be able to run this, right? So in here, we're going to do a few things differently in the run.ts. So firstly, we're going to create a new variable. This will be our entry point into the app or the console application. So this will be an async function, an anonymous function, and we're going to return a promise, and that would be a promise of void. So this is our function. And at the bottom, we're going to just run main. Great. Also, what we're going to need now is we need to set up our scanner. Now, I want to set this up in an agnostic way. So if I do const, I'm going to say NFT ID scanner. And this would be now equal to the Ethereum ID scanner. But remember, I want to keep the variable names agnostic for if we want to switch out the services later on. This should be fine for now. And remember, our Ethereum NFT ID scanner takes a few things, like the RPC provider URI. We can now get that if we go to the process.env.rpc provider URL. And you'll see it's red. It means that we need to put the bang operator there, which is the exclamation mark. This will just let it know that we are confident that we'll have that variable here for us due to our check here in the beginning. Okay, so we're going to do the same for the contract address.env, this. So, and then lastly, also for the holder's address. So process.env, like so. Great. Now that we have our instance, we can go ahead and create a try catch. This will be our main executions try catch block. Here, we basically going to, let's just put that. Here we're going to basically try and kick off our steps. Remember, if we look at the process flow itself, go through scanning the variables, then we have to get the token IDs, then we have to do the fetch metadata, generate wallets, and so on and so on. So this is where all these steps will happen inside of this try catch block. So when we do catch any error, we just want to give proper feedback using our utils error file that we created earlier on. So I'm going to start off by saying, let's get the NFT IDs. And these NFT IDs will be dependent on our NFT service. I'll scan it up here, .scan IDs. That's all. We are done for our very first step. Now we don't need to do anything with this variable at this stage. We can just leave it like that because we're going to pass it into the next step. But if I run this now, we actually should see this app reach out to that wallet that we configured and actually pick up that that wallet owns 4 of the NFTs and give us back those NFTs IDs. So before we run it, to make it just very clear, those IDs that they come back, just going to log out the NFT IDs for now as well. So let's go ahead in the terminal. Let's run tsnode run.ts. And as I do that, you'll see that we get scanning NFT IDs on this wallet. And then once it's done, hopefully we should get back those 4 NFTs. And there we have, we found 4 NFTs. And here's our log of each one of those NFTs IDs that's sitting in that wallet. And that is it. That is our very first step completed. So we've successfully made our service and could run it, and it can reach out and grab data through our RPC. The next step would be to resolve metadata, which we'll do in the next video. Yeah, and if you've enjoyed today's video and you've learned something along the way, let me know in the comments what you've learned. And also leave a like on this video and subscribe for more content like this. I really appreciate you guys and your feedback. So thank you so very much. And till next time, I'll see you in the next video. Cheers for now.